Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do construct a binary tree from pre-order and in-order traversal lead code problem. And if we see some of the companies where I want to get a job who have already asked this question, there are companies like Microsoft, Amazon, Bloomberg, Apple, Uber, ByteDance, Google, Facebook and LinkedIn. So that's why I am paying my utmost attention. I hope you also enjoy the video. Now this is a very hated lead code problem and let me show you why. This is from the solution tab of the LeetCode problem where people have expressed their views very abruptly. Some people are saying why God why, some people are saying that it's time to leave for Himalayas, some people are saying that if you get this question they do not want to hire you and things like that. There are many other comments. The thing is we do not want to focus on the negativity. Let's try to see that what is the approach to solve this problem, and then we are going to see that how can we be able to solve this problem if we encounter this in any interview, because our aim is to get into FAANG, not just dream about it. Now this is a LeetCode medium problem, but in my opinion this should have been a LeetCode hard problem. Now let's try to understand the problem. Basically we are given two integer arrays called pre-order and in-order, and basically they are the pre-order traversal of a binary tree and in-order traversal of the binary tree. Now based on these two arrays that we are given, we need to construct and return the original binary tree. So let's try to understand this with an example. So over here we are given as an input, we are given two different arrays, pre-order array and in-order array. Now somehow if we iterate over this pre-order and in-order array, there is only one combination of binary tree we can make, and which is this one. So that is the example that is given over here. Now let's see that what is going to be the different approach to solve this problem. But before we do that, the important thing in this problem is to understand that what is a pre-order traversal, what is the in-order traversal, and how can we use their properties to our advantage. So first of all, I'm going to show you pre-order and in-order traversal, how it works. So first of all, we are going to learn about pre-order traversal, and basically pre-order is a DFS kind of traversal, which is depth first search. If you want to know more about different kinds of traversal, you can check out my video over here. Now let's focus on the pre-order traversal for now. So basically in pre-order traversal, first of all we visit the root node, then we visit its left subtree, and then we visit its right subtree, and we keep on doing that until the nodes exist. So let's see that for this given example, what is going to be the path that we are going to follow. So first of all, we are going to visit the root node. So in this case, the first node we are visiting is going to be node number 5. Then we are going to visit its left child. So left child in this case is 3. So again we are going to visit node number 3, and then again we are going to visit its left child, because remember it's root, left subtree and right subtree. So left subtree still exists over here, so we are going to visit node number 1. Now left subtree does not, nothing more exist in the left subtree, so now we will start visiting the right subtree. So now we will visit the node number 7. Now after visiting the node number 7, now there is nothing exist over here, so again we are going to go back to the root, because we still have to visit its right subtree. So when we start visiting the right subtree, again we are going to follow the formula of root, left and right. So root node in this case is going to be 8, so now we are going to visit node number 8. After that we are going to visit node number 6, and then we are going to visit node number 9, which is the right subtree, and this is going to be the traversal path that we are going to take. Now let's see that what would be the in order traversal in the same manner. So again, as mentioned, the in order is also a DFS kind of traversal, but in this case the methodology we follow is that first of all we visit the left node, then we visit the root node, and then we visit the right node. So for this given example, what we are going to do is, first of all we are going to go to the left node all the way possible. So left node in this case is 1. So first node we are going to visit is going to be node number 1. Now for now we can't go left anywhere, so now we are going to visit its root node. So root node is in this case is going to be 3, and then we are going to visit its right node. So right node in this case is going to be 7. After doing that, after visiting all 3 nodes, now we don't have any more nodes to travel on the left subtree. So now we are going to visit the root node as mentioned over here, because we have already taken care of this left part. So now we are going to visit node number 5. Now again we still have values that we need to visit on the right subtree. So again we are going to take on the same initiative. So now the first thing we are going to visit is going to be the leftmost element for this right subtree. So leftmost element in this case is 6. So we are going to visit the node number 6 over here. After that we are going to visit the root node, which is 8, and then in the end we are going to visit the node 9 over here, which is this one. So this is how in order traversal works. So after understanding both the values and both the different traversal mechanism, let's see that what would be the optimal solution and how we are going to approach that. Okay, suppose this is the binary tree that we are given that we need to iterate over, and we are given the pre-order and in-order traversal for both of them. So in this case, the pre-order traversal for this tree is going to be and the in-order traversal in this case is going to be. Now once we have both the values, let's see that what is the approach we are going to take. So if you closely observe both of these values for pre-order and in-order traversal, they both have something to offer. The thing they have to offer is that this pre-order allows us to determine that what the root of any section of the tree is, and this in-order allows us to determine that what is the left subtree and what is the right subtree of any given tree. How? Let me quickly show it to you. So if we see this pre-order traversal, the first value in this case is actually the root of the binary tree, which is 5 over here, which you can clearly see that the 5 is the root of the binary tree. So well, that is interesting information, but the thing is this alone is not helpful. If we see with this in order traversal for this 5, if we see the left side of this 5, there is only one entry over here, which is 3. And if we see in this tree, actually this 3 is the left subtree of this entire tree where the root is 5. Now if we see on the right side, the values are 6, 8 and 9, which is these 3 items, and this is actually the right subtree of this original given tree where the root value is 5. So now we actually have something meaningful that we can use. If we keep on repeating the same process, now for this pre-order traversal, again we see, okay, so the next value is 3. So 3 is already the left subtree. Now if we again break it from this in-order traversal, for this in-order traversal, we only have 3 value over here. We have nothing on the side, we have nothing on the right side, because the right side value is actually 5, which we have already identified that that is the root of this original value 3, which means we can determine over here that for this 3 it does not have any values on the left subchild and right subchild, because the very next value of this 3 is actually 5, which was already the root of this value 3. So now again we have some meaningful information. So far let's backtrack. The information we have found so far, that let me create an answer value over here where we have already found that the first value is 5, the leftmost value or the first left value or left subchild of this value number 5 is actually 3, and for this 3 it does not have any more children, so now we can add the values null over here. Okay, now we are done iterating up until this point, but we still have some more nodes that we need to iterate over. So based on this pre-order traversal, now the next node we have is 8. So now we know that the current root we are iterating over is actually 8. Okay, so we have this value 8. Now from this in order traversal, we actually have these 3 values where this 8 is actually in the middle, because remember this in order traversal allows us to determine that what is the left subtree and right subtree of any given root. So in this case, if the root is 8, then the left subtree is going to be the value 6 and the right subtree is going to be the value number 9. So we are going to use it to our advantage. Now for this value number 6, again we are going to try to see that what is on the left of 6 and right of 6, but in this case, since we don't have any more information for this value number 6, the left value is 5, which was the original root which we have already iterated over, and this next value is 8, which was the root of immediate root of this value number 6, which we have already iterated over. So now we can determine that for this 6 we don't have any other value, so which means that we have 2 null values. So again, now and same thing we can determine for this 9 as well, that for this 9 the leftmost value is actually 8 and in the right there is nothing over here, which means this 9 also does not have any more children. So now let's again backtrack based on the information we have found so far. So now on the right side, the value we got was 8, that was the root we iterated over, and we found that information based on the pre-order traversal. After finding this 8, now we started iterating over the left and right children of this 8. So left children was 6, so we iterated the value 6. Now the 6 did not had any more children, so we had the values null over here. And now then we had the value number 9, and 9 also did not have any more children, so now again we had the 2 more null values over here, and this is the actual binary tree that we were able to create based on this original given pre-order traversal and in-order traversal. And that is the solution that your interviewer is expecting, and that is what is needed for this problem as well. Now there are actually 2 ways to do this problem. There is an iterative way and there is a recursive way. If you know me, I love the recursive solution, so I'm going to opt for the recursive solution. Basically what we are going to do is, initially we are going to find the root value, and then we are going to find the left subtree and right subtree. Now again we are going to pick one value, so we are going to pick the left subtree. So now even for the left subtree we will have a root value and its left child and right child, and again we are going to keep on repeating the same process, and we will be continuing to building our answer. And same thing we are going to repeat for our right subtree as well. So basically we are taking a bigger problem and then dividing it into a bunch of different smaller problems. I know this looks really messy, but you get the idea of what I'm trying to convey over here. And let's see the time and space complexity in this problem. So time complexity is actually going to be big O of n, where n is the number of nodes that are present inside any given tree, because we will have to iterate over both in order and pre-order traversal, and originally it's going to be 2n traversal. The thing is, generically we can write it to big O of n. If we see space complexity, well, space complexity is also going to be big O of n, because recursively we might have to iterate over all the nodes, and it worst case scenario it could take big O of n space. This is a wonderful time and space complexity given that how complex this problem was, and based on the pre-order and in-order traversal we were actually able to build the solution for the binary tree. Now let's see the coding. So before we start coding, we will actually have to define that how we are going to use this pre-order and in-order array. Well, we are going to use this pre-order array to determine that what is the root value for any subsequent positions. And once we have the root value, we are actually going to use this in-order array to determine that what is the left subtree and right subtree for any given root. And once we have both the information, we are actually able to build our tree. Now the thing is, if you clearly understand that for this in-order array, we will have to look up at information much in much broader fashion than compared to this pre-order array. So what we can do is, in order to iterate over this in order array, rather than iterating it just by considering this to be an array, we are actually going to create a hash map where we are going, which is going to allow us to iterate over this in order array pretty fast. And so let me define two global variables over here. First of all, once we have these two information, now from our main method, first of all we will have to iterate over this in order array, and then we will have to populate this in order index map that we just created. So let me quickly run a for loop. Now we have our hash map ready to go. Now we will have to create a separate method where we are going to call the recursion. So first of all, let me create a new public method. So now I have created a new method called array to tree that returns a tree node, and as an input I'm taking the pre-order array, the left portion and right portion, and now we are going to create this recursive method. Now before I do that, I will also have to initialize the values for this pre-order index and also for this in-order index map, so that I'm going to do it. Okay, now back to our recursive method. So for recursion, first of all, we will have to create a terminating case, and the terminating case in this case is going to be that if the value of left is greater than the value of right, if that is the case, we break out immediately and we will return null. If that is not the case, first of all, we will have to define our root value, and root value we are going to define from our pre-order array. So our root value is actually going to be the whatever this pre-order index value that we have, and then we are also going to increment the value of this pre-order index as well. So this is the root value, and after that we are going to increment the value of pre-order index. Now since we have our root value, we are actually going to create a new tree node called root, and for this root node we are going to assign the value that we received over here. Originally, the value of this pre-order index is 0, which means that the first value we are getting from this pre-order is the main root of the tree. Once we get that value, we will have to create the left subtree and right subtree. So we will have to call this array to tree method again, and we are going to populate the value for left and right child. So for the left child, we are again going to call this array to tree method. Inside the input, first of all, we are going to provide this pre-order array as we found as it is. Now for the left subtree, we are going to keep the value same for the left value, but for the right portion, the value is actually going to be different, and that is going to be different based on whatever this root value we had. So in this case, for the first value for this pre-order array, the root value is actually 3. So now for the left part, we already have the value, but for the right part, we are going to have to provide all the values that are present after this root node. So we are going to do that. So for that, now our in order index map is very helpful. Now we have both the information ready to us. Now we are going to call the right subtree in the same manner, but in this portion we are going to treat whatever the right variable we had already, but now we are going to change the left variable. So for the left variable, we are actually going to use whatever the value we had for the root value, and we are going to do it plus 1. And as the right limit, we are going to keep whatever the right limit we originally had. And after this recursion ends, and after this function ends, we simply need to return the root variable. Okay, so now our recursive method is ready to go. Now all we will have to do is, from our main method, we will have to call this recursive method that we just created. That should be it. So we are calling this pre-order method, but we are providing the pre-order array, and as the left position, we are providing the value 0. As the rightmost position, we are providing the value of whatever the pre-order length is, -1. And that should do the trick. Now let's try to run this code. It seems like our solution is working as expected. Let's submit this code. And our code is pretty efficient compared to a lot of other solutions. I would be posting this in the comments, so you can check it out from there. Thank you.